This is 6.3b. Number 1, they want you to simplify if possible. So you want to check to see, because it's addition over here, you want to check to see if you have like terms. Now for radicals, you have to make sure that the radicand, which is the value in here, and the index here are exactly the same. If they're the same, then you can add them. So 5 root 6 plus 1 root 6 is 6 root 6. And that's it. When you add radicals, remember, you don't add the radicands together. So this would not be root 12. You leave the root 6 and root 6 as a root 6. You only add the number on the outside. So 5 plus 1 would be 6. Number 2, we want to simplify these first, because right now the radicands are not the same. 54 is not the same as 16, so we can't add them. But if we simplify these, we might be able to add them. So the cube root of 54, the highest perfect cube that's a factor of 54 is 27. So 27 times 2 plus the cube root of 16. So the largest perfect cube that's a factor of 16 is 8. So the cube root of 27 is 3. So we have 3 cube root of 2 plus the cube root of 8 is 2, and then we have the cube root of 2 here. Now we see that the indexes are the same, 3 and 3, and the radicands are the same, 2 and 2. So we can add these together. So 3 of these plus 2 of these is going to give you 5 of those. So 5 cube root of 2. Number 3, they want you to multiply. So we have a binomial times a binomial. So we're going to have to FOIL this out. So 3 times 5 is 15. 3 times negative 6 root 2 is negative 18 root 2. Negative 4 root 2 times 5 is negative 20 root 2. Negative 4 root 2 times negative 6 root 2 is positive 24 times 2, which is 48. So 15 and 48 together is 63. Negative 18 root 2 minus 20 root 2 is negative 38 root 2. And that's it. Again, this is another multiplication problem. We're going to be multiplying the conjugates together. Now, because we know that they're conjugates, we can multiply the F and the L and FOIL together. Well, the F's together and the L's together. So 4 times 4 is 16. We have a negative 2 root 3 times a positive 2 root 3. That's a negative 4 times 3, which is 12. And 16 minus 12 is 4. Number 5, they want you to rationalize the denominator and simplify. There are no radicals here that I can simplify to start, because there's no perfect squares that are a factor of 21, and these are as simplified as you can get. Actually, all 3 are as simplified as you can get. So we're going to go straight to multiplying the numerator and denominator by the conjugate of the denominator. So let's multiply the numerators together. So 5 times root 3 is 5 root 3. 5 times root 7 is 5 root 7. Negative root 21 times root 3 is negative root... Oh, that was a loud noise. I think it was a program that just timed out. So negative root 21 times root 3 is root 63. Negative root 21 times root 7 is negative root 144. For the denominator, we have conjugates. So root 3 times root 3 is 3. Negative root 7 times root 7 is negative 7. We only have to do F and L because they're conjugates here. So on the top, we can break down root 63 and root 144. Root 63 is the same as root 9 times root 7, which is 3 root 7. Root 144 is just 12, because the square root of 144 is 12. So if I rewrite the terms, I get 5 root 3 plus 5 root 7 minus root 63, we already found out was 3 root 7, minus 12. All divided by 3 minus 7 is negative 4. So let's just add like terms. I've got, I just figured out that I made a boo-boo. 21 times 7 is not 144. It's 147. So I gotta fix this just a smidge here. Change a little bit around. So it was 147. The square root of 147. So if I do that, 147 is 49 times 3. And that is 7 root 3. So this is going to be 7 root 3 up here. Okay, so now that that's fixed, 5 root 3 minus 7 root 3 is negative 2 root 3. 5 root 7 minus 3 root 7 is 2 root 7, all divided by negative 4. The last thing we can look at is the fact that we've got a 2, and a 4. All three of these terms are divisible by 2. So I can make that a 1, that a 1, and that 2 to get a final answer of negative root 3 plus root 7 all divided by negative 2. Alright, so this one is binomials multiplied. The only thing that we could simplify here is root 72. Root 72 is the same as root 36 times 2, and the square root of 36 is 6. So it's 6 root 2. So if I rewrite this, 1 plus 6 root 2 times 5 plus root 2, and then FOIL that out. 1 times 5 is 5. 1 times root 2 is root 2. 6 root 2 times 5 is 30 root 2. And 6 root 2 times root 2 is 6 times 2, which is 12. 5 and 12 is 17. Root 2 and 30 root 2 together is 31 root 2. Number 7, simplify. So r to the negative 4, s to the 0, t squared over r to the negative 1, s to the 4, t. So r to the negative 4 over r to the negative 1. You could do this a bunch of different ways. I could move the r to the negative 4 down to make it r to the positive 4, and r to the positive 4 times r to the negative 1 would be an r cubed down here. I could also ask myself the question, where is the exponent larger? It's larger for the r on the bottom and the denominator. How much is it larger? How many is negative 1 larger than negative 4? Negative 1 is 3 larger than negative 4, so you can write r cubed down here. S to the 0 is 1, so you can just cancel that. That would leave me with an s to the 4 in the denominator. T squared over t to the 1 is t to the 2 minus 1, or just t. And that's it. You could also say, where is it larger? That's on the top, so you put a t up here. How much larger is 2 than 1? 1, so it's t to the 1 on the top. Number 8, we have factoring to do, so let's use the box method. First term here last term here, the AC is 3 times 10, or 30. So it's 1 times 30, 2 times 15, 3, 10, 5, 6. Different signs, the larger one is positive. Which one adds up to a positive 13? That would be this one here. So I would put negative 2x here and 15x here. Positive, 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 negative. Remember, the signs here take on the sign of the box closest to it. Get a 15x and a negative 10x, or a negative 10, that gives me a 5. Factor out an x, 3x here, and a 2 here. So this gives me 3x minus 2 times x plus 5 equals 0. This gives me a 2/3, and this gives me negative 5. So negative 5 is one root, and 2/3 is the other root. Okay, number 9. This one over here, if you look at the lead term and the constant, both of those are perfect squares, x squared and 7. If you were to multiply those by 2, I would get 14x squared, which is the middle term. That's telling me that we have a perfect square binomial. So we would put the first term here. We take the middle sign, we take the constant and put it here, and it would be squared. If I were to solve this, I could write it out like this. If I were to solve this, I would get positive negative root 7 for both of them. That means that positive root 7 is a double root, and negative root 7 is a double root. Remember, double root and a double root, that would give you 4 roots. That means that we're fine because we have x to the 4th. We should have 4 roots as our answer. Number 10, what process do you use to identify like radicals? Like radicals are like common like terms. So when you're looking at a radical, you're looking at two different things. You're going to look to check and see if the index is the same in both, and if the radicand, which is the value inside the root sign, if that's the same. So like radicals have the same index and the same radicand. For example, if you had the 4th root of 7 plus 8 4th root of 7, you could add them because the indexes are the same, 4 and 4, and the radicands are the same. They're both 7. So you could add them together and get 9 4th root of 7. So again, to identify like radicals, you have to identify or notice that the indexes are the same and the radicands are the same. Then you know that they're like radicals.